Hi, Mr. Lee. I'm Aaron. Today I'm going to talk something about the preceding way. So here's the function, and there is the formula to get the secant between P and Q. So it's two possibility that point Q is on the left hand side of P and point Q is on the right hand side of P. So if it's on the left hand side, it is preceding way, which is if which is a preceding way. So if P is A F A, then the preceding then the Q is A plus H F A plus H. If it's a preceding way, the H is a negative number because it's on the left hand side. It should be smaller than the A. And if it's the following way, it's on the right hand side, then the H here it is a positive number. So let's look at how we get the secant of these 2 points. So here we can get the secant because it's changing y over changing x, just like this. It's changing y over changing x. So this is changing y and this is changing x, and this is how we get the formula. This is the general formula. But the limit here, it is supposed to is this here is h is approaching to 0. It is approaching to 0. So let's see why it's approaching to 0. So here is the tangent. So if we change the h value, let's say if it's a preceding way, the h is a negative number. So here, if we change the h value, make it approaching to point P, we can see that point Q is approaching to point P, and they're getting closer. And here, the orange line is the secant line, and the green line is the tangent line. So let's see if we approaching these, if we change the h value, let it approaching to 0, we can see these two lines are getting closer. They're approaching. So here we can see that how this formula works. Like when h is approaching to 0, we get the limit. So but it cannot work. It cannot always work. Like in this case, the function is here. The function is here, x power of 2 over 3. So here is a function, and we got 2 points, point A and point B, and we think that when point A is 0, 0, the IRC instantaneous rate of change does not exist. So let's see why it does not exist. So in this situation, we get the secant of point A and point B, which we use the green line to connect these two. So let's see why. So we have to look at the number here. This is our so here, let's see. So here in here the point B, A plus H F A plus H is on the right hand side of point A. So it is the following way. So if we change the value of H, here, let it approaching to 0. When we let it approaching to 0, look at this number here. When we approaching to 0, we can see this number is getting bigger and bigger. It's getting bigger. Yeah, now it's 1.03, and here it's 0.4. So we can see it's definitely getting bigger and bigger. So we get the conclusion that when the h value is approaching to 0, in the following way, when h value is approaching to 0, this m value is getting bigger, which means it's approaching to positive, which means it's approaching to positive infinity. And if we say that's in the preceding way, so if in the preceding way the B is on the left hand side of A, so the H here it's a negative number. So if we make it approaching to 0. So let's see. Look at this number here. Here is minus 0, negative 0.46. So if we approach into 0, so we can see here now it's negative 1.01, 1.01. Yeah, it's getting, which means it's getting smaller. Negative 0.4, negative 0.8, and this number is definitely getting closer to 0. It's approaching to 0. So here we can get the conclusion that in the preceding situation, this point, it is when it's approaching to 0, the m value is approaching to the negative infinity. So if we want to have an IRC, no matter the preceding way and the following way, they have to always approaching to the same number back here. This one is approaching to negative infinity, and this number is approaching to positive infinity. They are not going to approaching to the same number. So this graph, this function, it do not have IRC.